So in this video, we will be going through the derivative of cos of x step by step, and we'll be using the first principles rule. So let f of x equals to cos of x, and by first principles, f dash of x, so the derivative equals the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And that is by the first principles. And if you haven't seen the derivation of that rule, have a look at the top right, there will be a link to that video. Alright, that's equal to the limit at h approaches 0. We sub that in, we get cos of x plus h minus cos of x divided by h. And we can expand this cos of x plus h using the compound angle formula. So compound angle formula. And we know that cos of x plus h, that equals cos of x times cos of h minus sine of x times sine of h. Alright, and let's put that in. So limit as h approaches 0 of cos of x times cos of h minus sine of x minus times sine of h minus cos of x, all divided by h. Now I can group some stuff together. So limit as h approaches 0, let's group the cos x together. Alright, so cos of x, take that out. So we have brackets cos of h minus 1, close brackets, minus sine x sine h divided by h. Now before we move on, just make sure that you like and subscribe to this channel. It will really help, and yeah, and you'll see more of these kind of videos. Alright, so that's equal to limit at h approaches 0 of cos of x times cos of h minus 1 divided by h minus, plus limit of h approaches 0 of minus sine x times sine h divided by h. So I just split these two limits, and that's allowable by the limit rule. Right. That's right. Okay, now I have gone through these derivations in my previous video on the derivative of sine, but I'll just redo it here anyways. But there's a video on the top right as well that you can see as well, derivative of sine, top right video. Okay, so we just bring the x's and separate them from the h, right? Because we're just worrying about the limit as h approaches 0, so we're just concerned about the variable h. So let's find the limit as h approaches 0 of sine h divided by h. So first let's draw a sine graph, and if we look closely, for very, very small values of h, it's a linear graph. Okay, the sine graph looks like a linear graph for very small h. So as h gets really, really small, so in other words, h approaches 0, sine of h approaches, sine of h is basically the same as h. So sine of h divided by h, same numbers, so that gives you 1. Alright, now another one, let's do the limit as h approaches 0 of cos of h minus 1 divided by h. So let's draw my graph again. So my cos graph. And so as h approaches 0, so as h gets really, really small, cos of h approaches 1. Okay, and if we evaluate this, we have, just by substituting cos of h as 1, we get 1 minus 1 divided by a very small number, right? And this we can't really get. We get 0 divided by 0. 0 divided by 0, that is basically undefined. So we have to find another way to find the limit. So let's multiply both sides by cos of h plus 1. Okay, so rewriting it, limit h approaches 0 of cos of h minus 1 divided by h multiplied by cos of h plus 1 divided by cos of h plus 1. Okay, and that's equal to limit h approaches 0 of cos squared h minus 1 divided by h times cos of h plus 1. I'll just leave it factorized for a moment, and you'll see why later. And by the trig functions, we know that cos squared h plus sine squared h, that equals to 1. And therefore cos squared h minus 1, that equals to negative sine squared h. And so let's substitute that in. That equal the limit as h approaches 0 of negative sine squared h divided by h cos of h plus 1. And let's split this into two limits, so sine of h divided by h, and limit h approaches 0 of sine of h divided by h cos h plus 1. note that there should be a negative for the right limit. Should be a negative sine h. Alright, so the limit h approaches 0 of sine of h divided by h, that approaches 1, as we figured out before. That equals to 1, multiplied by the limit h approaches 0 of sine of h divided by cos of h plus 1. If I draw my sine graph and my cos graph, as h approaches very, very small values to 0, sine of h approaches 0, and cos of h approaches 1, as you can see from the graphs. So that basically is 0 divided by 1 plus 1, and that gives you 0. Alright, so now we have all the ingredients. Let's put it back into the expression that we had before. So the 1 and the 0. So going back to that last line will equal to cos of x times that limit. So that limit, we know that gives you 0, so times 0, minus sine of x times that limit, which gives you 1. And therefore we have negative sine x. I hope you enjoy. See you next time.